Hey everybody, welcome to topic number 26, application of simple interest. So in this video, we're going to talk about simple interest and we're going to talk about compound interest. Compound interest is basically derived from simple interest. That's why the title is only simply say simple interest. So what is a simple interest? Simple interest formula is actually the fundamental formula for financing, okay? Financing loans. So anytime we talk about borrowing monies, okay, we are using this simple interest formula. Now, financial industry they use a little bit, they might use a little bit different version of the simple interest formula or a formula that is derived from the simple interest formula. But the overall idea come from this most fundamental basic formula called I equal to principal times rate times time. I stand for the interest. Okay. Interest is the amount charged by the lender for borrow money. That's I. P is your principal. Okay. The amount of money that you borrow. R is your interest rate. Okay, so sometimes when we talk about APR, okay, APR is a type of interest rate that is commonly used. So the interest rate R we are using here is not quite it's not quite APR, but we can view it as APR, if the problem is calling for it. T is time. Time is normally in years, the length of the loan in years. Okay, so I equal the principal times rate times time. So basically, the entire formula consists of two terms, right? The PRT is only one term, okay, because this is multiplication between three things. I is only one term. So this whole entire equation consists of basically just two terms. So when we solve for anything, if we need to solve for any one of the unknown variable on the right hand side, then we will use the same idea as we did before with the proportion, when we do the cross product, divide both sides by the coefficient. All right, future value. Future value is referring to the amount of money that need to pay back. Okay, so what do you pay back? Well, you pay back what you borrowed and you pay back the interest. Okay, so the future value is always going to be the principal, the money you borrow plus the interest. Okay, so for example, find the simple interest. Okay, you gotta read very carefully what they want you to find. Find the simple interest. So that means finding the I on $980 for 5 years at a simple interest rate. So this is a key phrase right here. This tell you what formula you're gonna use. We're gonna use a simple interest rate formula of 12%. Okay, round the answer to a near cent. So 12% is your interest rates are, and we're gonna put them in the decimal notation. So I is the interest is equal to borrow 980 principal times the rate 12% is 0.12 times the time is 5 years. Time always got to be in years. If it's not in years, then we got to convert into years. So the interest that I borrowed, the interest that I will be charged on is going to be $588. Okay, so that's the interest I will pay. All right, what is the future value? So now it's asking me to figure out what I need to pay people back. So when we pay people back, we're gonna put principal plus interest. So that's the last thing we will do. $4,200 invested at 5% simple interest rate for 120 days. So this problem is not necessarily you borrow money. This is more like investing money. Investing money simply means that you are actually lending your money to the bank. Okay. Then they will pay you the interest. Okay. So rather than you borrow the money, you're actually lending the money to the bank. So $4,200. So what we're missing here is the interest, right? We need to figure out the interest first. We know to find the future value. We know to find the future value, you need the principal, which is 4,200 plus the interest. So we need to find the interest first. So 4,200 is the principal we invested times 5%, 0.05 times. This is 120 days. Okay, this is not years. So the way we convert it is to say 120 days out of 365 days. Okay, in the business world, there's only 360 days. Okay, but here we can still use 365. That will be okay. So I'm gonna show you how to put this in the calculator. 4,200, right, times 0.05 times, since this is a fraction, to be on the safe side, I'm gonna put that fraction in the parentheses, divided by 365. All right, so the interest is about $69.04. So the future value will just be what I invest, the principal, plus the interest. Okay, so that will be 42.69 and 4 cents. So this will be how much money in my account after 120 days. All right, another type of formula is called the compound interest formula. Compound interest formula is basically your basic formula or fundamental formula for investments. Okay, most of the time when we talk about investment is long term. So rather than do the simple interest formula over and over and over and over, simple interest formula can be derived into what we so called the compound interest formula. Investing money like like savings account, your CDs, certified deposit, right? CD, and money market account. That's referring to maybe like mutual funds, mutual funds. All right. Compound interest is interest that is being computed based on both the principal and the accrued interest as additional principal at each interval. So what I mean is, let's say we have this $4,200, right? Okay. So the end of the first year, you will have, so much money in here. And so much money in here is the 4,200 plus the interest you earned. So then you take this entire amount and roll it into the second year. Okay. And so at the end of second year, you will have even more money. Okay. Because you had what? You earned additional interest, right? Plus the interest you earned in the first year. All that is add on to the principal. Okay. That's why here it says is computed based on both the principal and the accrued interest as additional principal. So it's basically you started with some money and the interest you earned at the end of the first year add on to what you earned. So it's almost like this example we have here. You take the entire 4269 and roll into the next interval of investment. So so therefore you will actually earn even more interest. Okay, that's the idea. It has a snowball effect. It's basically basically something called a snowball effect. You start off with some certain amount of money, and then you put into this compound interest and then roll it down the hills. Okay, as a year goes on, that little bit of money grows bigger and bigger and bigger and bigger. All right. So capital letter A right here, okay, in the formula stand for future value, which is the total amount of money that has been accrued, excuse me, not accrued after compounding. Okay, that's the total amount of money in your bank account. P is a principal, your investment. T is in years. R is your interest rate. The lowercase n stand for compounding intervals. How many times does it roll over in a year? Okay, so if the problem says annually, that means account will roll over once a year. Okay, roll over means take the whole entire amount of money and then roll it into the next year's, interest, interest computation. All right, semi-annually means we will roll over twice a year. Quarterly, and it will be 4. Okay, monthly, and will be 12, and daily, and will be 365. Okay. Now, the same capital letter A, other than called the future value, can also be called the adjusted amount A due to inflation. okay, or adjusted amount A due to depreciation. So depends on the problem. So these two formula are basically the same as a compound interest formula. So where is the lowercase n? Where's the n go? Well, n is going to be 1 for inflation and depreciation. Inflation and depreciation is calculated once a year. That's the reason why you don't have to do interest divided by 1, raised into the 1 times t power. Okay. I just took those out. So this is basically the formula you will use to to compute inflations using plus sign or depreciation using subtraction sign. So certain things that we purchase does depreciate over time. Okay, so let's take a look. I'm gonna write down the formulas down here in a little bit. All right, let's say a couple deposit $22,000. Okay, one lump sum into an account earning 7% annual interest for 20 years. So find the future value if the interest is compounded daily. Okay, you gotta see this word. When you see compounded, that means we're gonna use the compound interest formula. When you see daily, then n will be 365. So we take the so you don't have to add, you don't need to add the principal plus the interest to find the future value, because that's only for the simple interest formula. This compound interest automatically has the principal and the interest together already. So the answer automatically has both principal, what you put in, plus all the interest. So we'll take the $22,000 times 1 plus R is 0.07 divided by daily is N is 365, raising to the N times T power. So that'll be 365 times 20. So in a calculator, what I want the calculator to do is do the exponent for me. Okay, so I'm going to put the extra parentheses. So we take 22,000 times parenthesis 1 plus. The calculator automatically is going to divide before add the 1. Okay, so you do not need the extra parenthesis. We want the division first before plus the 1. The 1 representing 100% of what you earned from last year is rolled into the next year. You can think of it like that. Divided by 365. Okay, exponent key. Okay, is this caret key? Or if you have a scientific calculator, you might be looking for something like an X with a little box on the top. Okay, or you can find this caret key. Raising to the, okay, I'm gonna put an extra parenthesis for this 365 times the 20. Okay, without that parenthesis, it's not gonna work. And my answer, so after 20 years, this account will actually grow into 89,202. And 42 cents. So inside this $89,000, it still retains the 22,000. So if you take the future value and subtract in, that tell you that this account actually earned you about $67,000 worth of interest. Okay. Suppose that $14,000 deposit for 6 years at 5% APR. Find the interest earned. So this is exactly what I just did. Find the interest earned. So once I find the future value, the total amount, I need to subtract the 14,000 to find the interest earned. All right, so let's plug it into the formula. 14,000. Okay, I'm looking at the formula up here. Times 1 plus 0.05 divided by compounded quarterly. Quarterly means n is 4, raising to the 4 times 6 years. Okay. 1 plus 0.05 divided by 4, raising to, I'm gonna open the parenthesis for the 4 times 6, close parentheses. Voila, 18862, 18862.91. Yep. All right. So that's the total amount in the account after 6 years. So how much interest earned? Your interest earned will be take the total amount of money in your account, subtracts what you put in, and that will give you the interest. 4862. 0.91. There you go. That's how much interest is earned. All right, a new van is valued at $36,200. What would its value be in 2 years if it depreciates 12.5% per year? So this is a depreciation. Okay, cars depreciate. So let's use this formula. Okay, T again, T got to be in years. So the future value, this future value means what's the value is gonna be after so long it depreciates. 36,200 times 1 minus, right? 12.5% is 0.125 raised into the second power. So brand new van, 2 years later, at a depreciation of 12.5%, 36,200, 1 minus 0.0125 raised into the second power. 2 years later, the van is worth 35,300. 60 what? 66 cents. Okay, depreciates over time. If the value of your house is $195,000 today, and inflation is constant at 10.9% annually, okay, what would be its value in 16 years? So houses actually appreciate. Okay, so let's find out this $195,000 home will worth how much after 16 years at the 10.9% inflation rate. So 1 plus 0.109, right? 10.9% raised into the 16th power. One nine five zero 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 0.109 raising to the 16th power. The house will be valued at, ooh, that's a lot of number, 1020, 796. All right. So it's over $1 million. Yeah, it's over $1 million. Now, here's the thing though, because of competition, okay, because of competition, you know, maybe the house is not going to be over $1 million after 16 years. Okay, competition is what keep inflation in check. Okay, so think about this: without competition, then somebody can actually monopolize, right? And then they can charge whatever they want to charge. So throughout United States history, there's a lot of there's a lot of cases go up against go up against big corporation who monopolize, okay, it's it's markets. So competition keep inflation in check. So think about this is house inflating, right? House, the price of the house inflation. Okay, so if cost of goods, okay, is at this high inflation, then something costs so much money now. In the future, it's gonna be so much more due to inflation. So because of competition, you can actually keep the pricing, okay, in check. All right. So this future, this inflation problem also applies for things you buy, okay, the things that you purchase. So if I just take off some zeros, okay, if I just saying, okay, maybe like a movie ticket is like, $19 right now, right? Movie ticket $19. 16 years later, at 10% inflation rate, hell, that $19 ticket becomes $99. Who's gonna pay $99 for a movie ticket? You know what I'm saying? So that's the reason why competitions, you got all the different kind of movie theaters out there. Therefore, competition keep that price, in check. It's not gonna jump up, at us all of a sudden. All right, let's take a look at some homework questions. Compound daily means n is what? 365, right? Inflation is usually calculated annually, semi-annually, quarterly, monthly, or daily. Got to be annually. Inflation is always calculated once a year. All right, solve the following application problem. Find the simple interest owed. So this one is a interest owed. So that'll be I equal. Okay, so 1300 times what? 0.085, right? Times 8 years. Then that will give you the simple interest. All right, what is the future value of $990 invested at 7% simple interest? So again, this problem I'm using a simple interest formula. So once you put 990 times 0.07 times 84 out of 365, right? 84 day out of 365, then all you get is the interest. So to find the future value, you got to take that interest and add on to the 990. Okay, make sure you run through your cents for these money problems. Number 5. Okay, how much would you have in 5 years if you purchase a $2,000 5-year savings certificate that pays 4% compound quarterly? So this one you got to use compound interest formula because they say the word compound. So n is going to be 4. Okay, so plug into the formula and see how much that $2,000 savings certificate become after after 5 years. Okay, a couple deposit $1,500 into an education saving account, earning 12% annual interest for 18 years. Find the future value. The interest is compounded annually. So annually here, n is 1. Okay, let's see how much the money. So remember now, this deposit is a one-time deposit. Okay, this is a one-time deposit. This is not like it's not like people's 401k. Okay, if you have a 401k or if you know somebody have a 401k at work, then those are a little bit different because you contribute to your retirement like 401k every pay period. Okay, that's why those money will actually exponentially explode quicker as compared to simply just do a one-time deposit. Okay, so if you ever wonder why some of these future value is not very big, that's the reason why, because you only put the money in one time. It's not like you constantly periodically put the money into that account. Therefore, it doesn't grow as much, right? If you just put it one time, it's not gonna grow as much as if you're constantly putting money in it. Plus all the compounding. An online company is advertising a name brand pocketbook on sale for 35% off for the original price of that. Okay, so the sale tax is 8%, excludes shipping and handling. What is the total amount including tax? So this problem actually come from the previous one. Um, Not quite sure why I put it here. Okay, so if you don't mind, do this problem. This is from the sales tax problem. 35% off the original price of 242. So this problem is a lot like the going to build buying that red coat. Okay. All right. Find the total amount, please. All right. Find the cost of the monthly rent for a two-bedroom apartment in 30 years. Yeah, assuming an annual inflation of 5%. So this is an inflation problem. So take your rent 690 times parenthesis 1 plus R 0.05 raised to 30 power. Now, then that will tell you how much the rent will be after 30 years. Okay, so that will conclude this video on simple interest and compound interest formula. Thank you for watching.